It's just water. All right, so today is 4.6b, which is related rates part 2. The reminders are up here. You had a Delta Math yesterday, the homework, etc. Tests coming up. You'll have a review. The review is not, it might be in my mailbox now, but it wasn't during my plan. So if you want to start early, the digital copy is up on eCampus. All right, you guys all know the rules for related rates, nothing new there. We're just going to do 2 different types of problems that you might have not seen before. They all involve topics, things that you could probably have figured out on your own, but it's just stuff that you haven't seen in a while. So that's why I want to review it. Okay, so it says 2 airplanes are both traveling towards Orlando. So what we're going to do is we're going to put a point as Orlando.
I know what that is.
Good.
I've been there.
I hope everybody's probably been there from this class. All right, so we have Orlando. The first airplane is traveling at 600 miles per hour and is 400 miles north of Orlando. So you guys all know what a compass looks like.
North is up.
North is up, south, west, and east. Okay, so north is above us. So here's the plane, okay, and it's coming toward Orlando. So we're going to call this y equals, its y is 400, but the rate at which y moves is what?
600.
So we call that dy dt, right?
Yeah. Oh, wow, that makes sense.
Yeah. So then next we have a plane traveling, and it's currently west. So it's coming from this direction. And technically it is a little bit shorter than the other one because it's a little bit closer. So we want to be technical here. So this we're going to call x, and x is what?
300.
300, and dx dt is what?
550.
550. Remember, rates are always dx or d whatever dt, and then the actual values are just whatever they are. And then it says how fast is the distance between them decreasing. So if you know about a compass, it's like a coordinate plane. These are right angles. Okay, so this is a right angle. That's important because now we're talking about the distance between the planes, how fast is decreasing. So of course, if the planes are moving closer and closer, what's happening to that hypotenuse? It's shrinking. Now, first thing we want to do, we're going to call it z. So to figure out how long z is when this is 300 and this is 400, I could just use what?
Pythagorean theorem.
Pythagorean theorem. So 300 squared plus 400 squared, and the square root is going to be what? 500, right? So the reason I knew that is because it's like a 3, 4, 5 triangle, but times 100. So everybody see how I was able to do that in my head. But it's okay if you didn't. You could just use Pythagorean theorem if you didn't remember it, and it'd come out just fine. Okay. We don't know what dz dt is. That's what we're trying to figure out, right? Dz dt is the distance. So it says how fast is the distance between them decreasing? That would be our distance, right? Between them is dz dt. So is everybody good with that? Now, in what way can we relate all of these things together using what formula? Pythagorean theorem. Exactly. So the reason, I just want to preface this for the next problem. The reason I'm going to take the derivative now is because all of these rates are changing. See how none of these values are constant throughout the problem? The one plane's moving, the other plane's moving, and the distance between them is also changing. Okay. So for that reason, we don't plug anything in ahead of time. We're going to take the derivative. Good class for you then. All right. Now we're just going to plug everything that we know in. So we know that x is 300. What's the rate at which x changes?
600.
That would be y.
What? Oh,
It's okay. I just want to make sure you don't plug it in the wrong guess. And then we know that z is 500, but we don't know what dz dt is. So we get here. Okay, and this is just a bunch of calculator stuff, right? So 2 times 300 times 550 plus 2 times 400 times 600. And then that's all going to be divided by what over here? 1,000. So we got dz dt equals 810 miles per what?
Hour.
Good. Remember, rates have to be something per something. Okay, usually time. All right, any questions about how we got that one? Okay, this one I think is fairly fair game for a test quiz, something like that. I don't think this one's too bad.
We had a problem like that on Delta Math, except without the
Yes.
I did
the word problem itself.
Yeah, they just give you the values of the triangle, right?
Yeah, they did.
Yeah, so you know that in Delta Math I did throw you some that you probably could figure them out, but we hadn't like addressed maybe one exactly like it, but now we have. All right, so this problem is a little bit more challenging, but we're going to talk our way through it. So it says here, a bird is flying horizontally 400 feet above the ground
Horizontally, that's up.
at a rate of 20 feet per second towards a camera on the ground. So if we have a camera on the ground here, okay, the bird we know is 40 feet above that camera.
Straight up?
Straight. Well, we don't know where the bird is, but we know his horizontal distance that he's going to fly is 40 feet above. He's flying in like a horizontal line. So the line at which the bird is flying is like this right here. Okay, and the bird's flying perfectly. We're going to assume the bird's flying perfectly horizontally, like a perfect 180 parallel with the ground. Okay, I know it's not perfect, but we're estimating.
So bad.
So here's the little bird, okay, and he's flying at a rate of 20 feet per second towards the camera. But he's not actually, when I say he's flying towards the camera, he's not flying directly towards the camera. That would be a diagonal. He's flying above, like towards above the camera. Do you see what I'm saying by that? He's passing over it, okay? So, of course, when he's directly over the top, he's going to be 40 feet away from it. And then it says, how fast will the camera angle change when the bird is 50 feet from the camera? So this is his raw distance from the camera. His raw distance from the camera is going to be what?
50.
Yes, which is going to be the
Hypotenuse.
hypotenuse. So that's his raw distance from the camera at that given moment.
Wait, how's that 50? That's 200 to the square root.
It says 50 from the camera though.
Because it's 400 and the square root of that's not 50.
Where are you getting 400 from?
16 and then
This is not the side lane. This
that's how fast the bird
This is the rate. This is the rate. So yeah, so this right here is dx dt. We don't know what x is yet. So maybe that makes more sense. Okay. So we don't know what x is, but we can find x using what? Pythagorean theorem, so we're going to get what?
300 or 30.
30 feet. Okay, so you could do this using Pythagorean theorem, but if you know it off the top of your head, that's fine too. A lot of these problems are set up for AP tests. They don't have a calculator for some of them, so that's why they're set up that way. So, but you do. Anyways, so what we want to do is figure out, in this scenario, are any of these values constant? Is any of their rates of change 0?
Why?
Why? Because the distance that is above the camera is not going to change if the bird is flying straight horizontally, right? His vertical distance is always going to be 40 feet above the ground. Is everybody good with that? So this right here, you can say dy dt equals 0. We don't have it. So that means that basically, when we end up taking our derivative, we can plug this in right ahead of time before we take the derivative because it's what?
0.
Or constant, right? It's
Yeah,
a
it's
constant
constant.
value, which means its rate of change is going to be 0. So yes. So here's where the things get a little wonky and out of control here. It says, how fast will the camera angle change? They're not even asking about the rate of the sides. They're asking about the angle of the camera. So we're going to call this angle theta. Theta is a variable, okay?
Am I going to be doing the stuff I did in like trigonometry?
Yes.
Yeah.
So this is the camera's angle, and the camera angle's changing at a rate of d theta dt, correct? That's what we're trying to figure out. We're trying to figure out how fast the camera angle is changing. Now, right off the bat, there's some stuff we can figure out additionally other than x, right? We can also figure out what theta is using trigonometry, right? So there's a few different options here. You got sine, cosine, or tangent. So you can actually use all of them because we have all the sides, correct? So I'm going to use tan. So tangent of theta is equal to what? Opposite over. So what's our opposite side here?
30,
And our adjacent side?
40.
40. So if you all remember how to do this in the calculator, you would do 30 divided by 40, and then you would do second tan. But make sure you're in degrees, because if you're in radians, not wrong. Just depends what the question's asking, but just make sure you keep it consistent throughout the problem. So I'm going to keep it in degrees. I just like degrees better. It's just my personal preference. So 30 divided by 40. And then remember, when you want an angle measure, you hit second tan.
Thank you.
So we get second tan of 3 divided by 4, which is about 37 degrees.
Yeah, 37.
Okay? So we get that degree measure. So now we're ready to set up something to find the rate of change of d theta dt. Now, if I set a Pythagorean theorem, is that going to help me find the rate of change of the angle?
No.
No, because it doesn't involve angles at all. So what we can do instead is we know that tan of theta is equal to opposite, which is x, over adjacent, which is what? Y. So this right here, this formula will give me the comparison between the angle and the rate of change. Now here is the thing. Anybody tell me why I wanted to do tan instead of sine or cosine here? Sine or cosine would have inevitably involved the what? What am I missing about the hypotenuse?
The rate of change.
The rate of change. So I want to pick two sides that give me, I have the rate of change of. Now I know I technically don't have the rate of change here, but I know that it's constant, so I know the rate of change is 0. So if I were to try to do this one, I would end up with dz dt in the formula, and I can't solve for that.
Yeah.
So you want to pick one that you have the rate of change for. Now, to be realistic, we could have found the rate of change of this using Pythagorean theorem and all that, but that's extra work that we don't want to do. So we're going to take the derivative here. What's the derivative of tangent?
Secant squared, yeah.
Secant squared theta, right, is equal to x over 40. Why can't I plug in 40 now?
Because it's a constant.
Because it's a constant. So when I took the derivative, I forgot one step, though. What did I forget? D theta dt, right? Equals. Now here, when I take, I guess I shouldn't have done this all in one step. This is 40. I can plug it in right away. So that's like 140 times x. What is the derivative of x?
dx dt.
Dx dt.
Wait, so, oh, I see. The
So-
1 came from the derivative of the x. I gotcha.
Yeah, sorry, this was tricky. I should have showed you this first, which is the same thing as 1/40th times x.
Yeah.
So this is the derivative. Now we know what theta is, correct? So we can plug it in. So this is like secant of 37 degrees squared times d theta dt, which we don't know. But we do know what dx dt is, which is what? What's dx dt?
It is
20.
yeah.
20. But there's one little other curveball here. dx dt is the rate at which the bird flies towards the camera.
It'd be negative 20.
It would be negative because what's happening as the bird flies towards the camera?
Getting closer.
It's getting closer, meaning this side is getting
Smaller.
smaller, so its rate is decreasing. It's tricky, I know. So this right here, we have a problem. Can you put secant in the calculator?
No.
Secant is the reciprocal of what?
Cosine.
So it's 1 divided by cosine of 37 squared times d theta dt. All equals negative 1/2, correct? So you just do a bunch of solving here, moving some things around. So I end up with negative 0.5 divided by, this is going to be hard to do in all one calculator run, but I'm going to try. And I got negative 0.32. And this is not going to be feet anymore, right? Because angles aren't measured in feet. So what is it going to be?
Degrees
Degrees per what?
per second.
Per second. So while the seconds remain, degrees, or you could have done it in radians as well. Okay, I would specify if I wanted it in radians. I personally just like degrees better. You'll see my preference to that, but you will have to be able to do both. So this is kind of a review of your trigonometry stuff. Now, I do want to show you one other little cool thing that you could have done here. And maybe this is going to be over your head, but do you remember the fact that if you wanted to rewrite this, it could be the same thing as tan inverse of x over y is equal to theta, right? That's essentially what you're doing in the calculator. So you know how to take the derivative of tan inverse, don't you? because this is really tan inverse of 1 over 40, or x over 40, right? Now I could take the derivative of both sides. Tan inverse, anybody remember what the derivative of tan inverse is? 1 over, remember that yellow sheet of paper?
Yeah, it's 1 over
X squared plus 1,
X
right?
squared, yeah.
So it would be x squared, this squared, plus 1, times the derivative of this, which is just 1/40th, equals the derivative of this. That's another way you could have done it.
Interesting.
Just thought I'd point it out
It's
because,
a lot easier to look at.
Yeah.
Wait, when does it become negative in the second one now? Does it become negative, doesn't it?
and this one I'm doing right here?
Yeah.
No, so this is the inverse. If I take the inverse of both sides of tan, this is going to end up being tan inverse of this, and then just equals theta. And then I know what the derivative of tan inverse is. We learned that in 3.9.
Yeah, but at the end, we got a negative value. How does that come out to a negative value?
It would still come out to be a negative. If you want to plug in your values, it will work out to be negative.
Okay.
Yeah. That one I say is a little more advanced way to do it. But I just want to point out the similarities between how everything kind of comes together. Yeah. Any questions about it? It's just really knowing your trig. So on number 3 on the homework,